This next section for 32C that we'll be discussing has to do with inverse functions. And inverse functions, we've worked with this before. If I had a 30, 60, 90 triangle, it's a 1, 2, root 3 triangle. And we wanted to find out what the cosine of 60 is. So we'd say, okay, cosine is adjacent over hypotenuse. So the cosine of 60 is 1/2. And this has all the answers in it of all 6 pieces of the triangle, all the sides, all the angles. But many times we run into it and we say, okay, well, the cosine of theta equals 1/2. And we put that in our calculator by saying cosine -1, 1/2. That doesn't mean it's an exponent of -1. It means the angle whose cosine is 1/2. Cosine of theta equals 1/2. You're looking for the angle. And we struggle with putting that calculator and we say, yes, I realize when I do this, I put it in the calculator as the cosine of the -1, so second cosine of theta equals 1/2, and that's how I use the calculator, and it would give me 60 as my answer. Now, there's an easier way to write this, especially when I start putting functions together, and these functions may be an expression that's really long, and that long expression may say, I want to find the angle whose cosine is 60 plus the angle whose cosine is 30. Well, that would be great, but I would end up with 2 equal signs in my equation. So there's got to be a better way to write that, and the way to write that is the arc cosine. This means the angle whose cosine is 1/2. That would equal 60. I could say the cosine of 60 is 1/2, or the arc cosine of 1/2 equals 60. The arc is the same thing as saying the inverse function. It's the opposite direction. On the calculator, if I hit cosine 60, I'll get 1/2. If I hit second cosine 1/2, I get 60. It allows me to go the other direction. Now, when I'm working in a quadrants of 1, 2, 3, 4 on a Cartesian plane, I realized that I would have a triangle, and I just went ahead and transposed this triangle over here. So there's my 1, and there's my 2, and that would put this as a 60-degree angle right here. And if I said, well, I want to find out in quadrant 1 the cosine, well, cosine is a positive number, like we had in the previous lesson. Cosine is a positive number because adjacent over hypotenuse. So I could say the cosine of this angle equals 1/2, and that would equal a 60-degree angle. The negative version of that, if I said, well, what about if I said the cosine whose angle is -1/2? So I would say arc cosine of -1/2. Well, how am I going to get that to be negative? Well, I know my radius can't be negative, so that means that my function up here, my adjacent, is going to have to be negative, and that's going to put me into that second quadrant. Now that's pretty simple, because I look at it and say, okay, so if this triangle has the arc cosine of -1/2 is going to be 60 degrees right here. But because of that, I could convert that 60 into 120 degrees, because that's where it is from here to there if this is 60. So the arc cosine of -1/2 is 120. It's in the second quadrant. Now, in order to make this work, there's different ways I end up with negative values for the ratio. Well, remember that it was all students take calculus? The problem is that means that I would end up with a negative value of the cosine in this quadrant as well. So by convention, we take the first 2 quadrants, or the 2 most standard quadrants that we can use, and say, if they're all positive, if the cosine's positive, it's in this one, if it's negative, in this one. And I ignore these 2 quadrants for making a function. Now, that doesn't mean it can't exist in those other quadrants. It means a function. And remember, functions have to be reversible. Because if I had a negative cosine, and that negative cosine could be in more than one quadrant, I have to go, and the positive cosine could be more than one quadrant, I have to limit my range between 0 and 180 degrees for my cosine function. For the sine functions, which I can work with the arcsine the same exact way, and I'm not going to go over that. I think that this is going to lay it out here, the same thing. I still have my same special triangles, my 45, 45, 90, my 30, 60, 90, and that still works exactly the same thing. It's just if I was using the sine and the arcsine instead of using the -1, I'm going to go ahead and lay that out the same exact way. The only difference between the cosine and the arc cosine and the sine and the arcsine is that the range is different. The range on the sine goes from a negative 90 all the way up to a positive 90. So it's a different range, and if you remember that you're all students take calculus, the reason why it can't be 0 to 180 like cosine is because they're both positive in these first two quadrants. Where is it negative? In the fourth quadrant. So what I'm going to remember is when I'm using inverse functions for my sine is going to be negative 90 to positive. My cosine is from 0 to 180. And that's going to be my range to make it so it's reversible. So I'm going to only use those when I'm going the other direction.